this is not good. Okay, so this is just illustrations about how to come up with the Bellman equations over there. Okay, so again, it's like now if you standing at the period t here, and I tell you that the starting initial capital you had is k, and assume that you already knows the optimal path, consumption path, which is C1 star, C2 star, and blah 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 blah. Okay, and then you will have the corresponding consumption utility. You just put that into the utility function there. So you have the utility for each period, and then you sum them up with discount factors 2, 3, okay, and you will get the value functions. Okay, and it's the same if you already standing in the period t plus 1, and I tell you that the same, you still have the capital K here. Then of course, the optimal consumption path is the same. C1, C2, D3 star, da da da, then the utility, and you discount it and get this one. But this two is not the same, because here is valued at t plus 1, while this one is valued at period t. So there's a discount over here. Okay, so that's why, in the end, I will write it this way. Okay, and that's how we write down the Bellman equations. Okay, yeah. Okay, so just for your reference, the final exam will be, I would say, will be easier than the waiver exam. Yeah, people just come to me and ask me about that question, and I think it's better that everyone knows. But that doesn't mean that you don't need to study. Okay, you still need to study. Okay, right. Okay, so now that we write down, we turned the original form, original problem here. Okay, so this is our original problem, and we write it down in one single equations, like here. Okay, but still, though, we haven't solved it, right? How are we going to solve it? And now I'm going to tell you how to solve it. So I think it's still good to show the step here. Okay, so the first step is to take the derivative with respect to k-plan here. So this is our objective functions. We take first order conditions, which you will get the derivative here and set it equals 0. Okay, and you will see that there's a term here. Okay, which you don't know why is that. How to get that term? We get that term by using envelope theorem. So again, the same functions, but now that we take first derivative with respect to k instead of k-plan, and you will get the functions here, like the equations here. And notice that this is to k here, and what we need is to k-plan. So you just change the state, like kind of like postpone it to the next period. So you replace k with k-plan and k-plan with k double plan. So this is how you get the terms here. Okay, and then you plug in into the first order conditions. This is the final result you will get. Okay, and this is actually on your left hand side is the marginal utility. Okay, so if we put c back to these equations, this is actually the first order derivative with respect to c on your left hand side. And we can do the same for your right hand side. You will get the first order derivative with respect to the next period consumption c plan. Okay, and what is these equations? This is Euler equations here. So we have interpretations for these equations. Okay, and I have the text here. You can read it. But the idea is that now that you decide how much to consume for this period, right? And since you don't consume, like you treat that as the saving for the next period. It will become the capital for the next period. Okay. So what is in your mind is that should I consume more or should I save more for today? Okay. And how you are going to make that decision optimally? You have to compare the marginal benefit you sacrifice today, which means that, okay, if I want to save more, that means I need to give up this proportion of utility, which is, I didn't consume it. If I don't consume it, then I won't get this amount of utility, right? This is the utility, the benefit that you sacrifice today, okay? And what will you get by sacrificing those consumption? Like in turn, they will give you extra output because now I save something, it becomes capital for the next period, and that is going to increase the production